Statistic is the bridge between the theoretical world, the models of science, and the empirical world, the data, the raw material. Models are theoretical constructs to understand the world, to have an insight of the complexity of the world, in this case, of the complexity of a malady, a disease. And then data is the way in which sentences gain knowledge about the real world, and statistics makes the connection, the liaison, is the intermediary between data and models. In this way, we can say that statistics is the technology of the scientific method. It's key to gain objective knowledge, and is the sine qua non objective research cannot exist. Clinical research and clinical decision use objective evidence based on well-designed research. This means to know statistics. Diagnosis and treatment require statistical thinking. A medical doctor without knowledge of statistical principles cannot rely on its own criteria to make decisions. Multifactorial and complex diseases are in nature statistics. You know to know what is the probability of the disease given a number of symptoms, and in this way you also have to be aware of the false positive, false negative, and without knowledge of statistical element of reasoning, you cannot make good diagnosis. Big data makes statistical even more necessary to make research, and also much more complex and diverse. Why? In this case, with big data, we have additional problem. The problem of data quality. So you have some bias in the data because you have even if the bias is very, very small, because you have so big amount of data, this will give a significant result when the origin of the problem was in the bias even in the small problem with sampling of the data or structure of the data. Then we have a problem of quality. We have to be very, very concerned about how to control the quality of data. This is a very typical problem in big data analysis. Also, we have a computer problem, how to deal with technically with this amount of data and the power to analyze all the interaction, all the potential analysis of this data. And finally, we have statistical problems in a serious problem in the sense that we don't make a single test of hypothesis. We can do simultaneously millions of tests of hypotheses. That means you have enormous amount of false positive, and is a very difficult task to separate the false positive that the true positive in any data analysis. Then, in some way, big data exacerbate the problem of data interpretation. In this sense, statistical analysis become much more important. In fact, we now, with the big data, talking about a new paradigm in science, what we call data exploration or data science. Usually, science is thought they start with a null hypothesis. You have an hypothesis about a phenomenon, and you test for this hypothesis. Because we have so big data in medicine, in other field of science, then the potential hypotheses are so many that you can test, that the first step is to make a complete analysis of the data structure. And then from this analysis of data, you gain a new knowledge that was probably not expected in any previous hypothesis. In this sense, this new paradigm of science promoted or fostered by big data is a new moment in the history of science. Big data analysis, data science is now the paradigm. And then my advice to any new scientist or scientist or doctor in this case that want to improve or to be updated with the new knowledge and challenges, to pay attention to big data and the statistical problem associated with this big data. In this sense, I think my best advice is try to learn all you can about this field, because the present and the future go in this direction. Another thing is you don't need to gain a high level of specialty. You know the main principle, how does it work, and then I'm sure with courses like this you will gain this knowledge.